All right, everybody, I am back. This time for my Algebra 2 class. So today I'm going to be further analyzing logarithm functions and equations. So I'm going to be looking at logarithm equations now. Okay. And in order for us to do this, I'm going to do a quick little review. I'm going to review solving exponential equations. Let me know who you are, my viewer. I miss you, students. Solving exponential equations, okay? So remember when we're solving exponential equations, we need to make sure that on the left and the right of the equation, we always make sure we have the same base so we can then analyze either the powers or make certain movements. So let's go ahead and do an example. I'm going to say if I have 2 to the x is equal to 8, how do I solve for x here? So notice this base is 2. Can I turn this 8 into base 2? Sure can. 2 to the x means 8 can be turned into 2 to the third. Now that I have my bases are equivalent, so when my bases are equivalent, I can now proceed to say, well, my solution is x equals 3. How? Remember, whenever we use a solving equation, I have to verify. So to check, I go 2 to the x is equal to 8. Let's see. 2 to the third, I replace with my solution. 2 to the third, is that equal to 8? Yes, 8 equals 8. I got a true statement, so now my answer is valid and legit. Let's go ahead and do one more just so we can see that it sometimes can be a little bit more than that. Let's go ahead and do 3 to the 2x plus 1 equals 81. Okay, so now here, again, I need to have the same base in order to further analyze this equation. So 81 can be turned into base 3. Let's see, 3 to the 1 is 3. 3 to the second is 9. 3 to the third, 3 times 3 is 9, times 3 is 27. And 3 to the fourth is 81. So here's my hefty calculator. I'm going to go ahead and go back into my calculation. Does 3 to the 4 equal 81? Yes, it does. So instead of writing that 81 as such, I'm going to go ahead and write it in its power format. So 3 to the 4. So now I know that I have the same base. So then I can now go ahead and analyze just the powers. So that means that I now know that 2x plus 1 is equal to 4. So now I get to solve for x, basic algebra here. 2x is equal to 3, divide by 2, so x is equal to 3 over 2. So we're going to go ahead and see if that's valid. So I'm going to check 2x plus 1 equals 81. I don't know, we'll see right now. So I have 2 times 3 halves plus 1, does that equal 81? So 3 times 2 is 6, 6 divided by 2 is 3, so I got 3 plus 1, is that 81? That gives me 3 to the 4, and yes it is, true statement, this answer is valid. So a quick little review on solving exponential equations, because now we're going to go into solving logarithm equations, and we have to understand that equivalency. So I'll write it down. We recognize, here we go, recognize that we have log A of y equals x. Yes, because remember, a to the x is equal to y. So these two things are equivalent, right? That is the relationship between an exponential function and its inverse logarithm function. So I'm just going to leave that there. I'm going to go ahead and do another example. I'm going to ask you to solve the following. So what happens when I have log 2 of x is equal to 3? How do I solve for this one? I have to understand this relationship in order for me to solve it. So I recognize that if I do this like this, I know that 2 to the 3 is equal to x. Simplifying that, I get x is equal to 8. So how do I check it? Is log 2 of 8 equal to 3? Yes. So I recognize that that is solved right there. Yeah. What happens if I have, let's do one more. And I'll use my 81 again. So let's say I have log 3 of 81 equals 2x plus 2. Okay, same thing. I'm going to go ahead and use my rule that says this to that power has to give me that. So 3 to the 2x plus 2 power gives me 81. So do you see how I turned this logarithm equation into an exponential? So same thing as I did in my previous example. I now let that equal to the same base. Now that I do have the same base, I'm able to just do the analysis of the numerator of the power. So I recognize that I now have 2x plus 2 equals 4. I'm going to go ahead and use basic algebra to solve for this. And this gives me x equals 1. Let's see. Does log 3, I'm checking this by the way, of 81 give me the answer that I'm looking for? So I know that log 3 of 81 is 3 to the 4th power is 81, so I know that that is 4. And does that give me 4? Bam, it does. So a quick little snapshot of solving logarithms. You're going to have some homework in solving logarithms. But now I'm going to go ahead and now talk about some logarithm rules. And for this, I must remind you, if this is a good time for you guys to go back and watch my video on my exponential rules, the Howdy way, because now I'm going to tell you the logarithm rules. So again, I must showcase my first one is multiplied, right? So remember that multiplied had the following. A to the m times a to the n gives me a to the m plus n. Okay, so I'm going to prove this to you using substitution and basic knowledge of our logarithm already. So remember, this is multiplied. That says if I have an exponent and I multiply it by another exponent of the same base, then I simply just add the power. So now we're going to analyze this through the lens of logarithms, okay? The very first thing I got to let you know is I'm going to use substitution. So I'm going to let x equal a to the m, and I'm going to let y equal a to the n. So far, so good? Okay. So we recognize if I let this equal to that, I recognize now that I am able to say, since x is a to the m and y is a to the n, then I can say x times y is a to the m plus n. All I did is I said x is that guy, y is this guy, so I just use substitution. So can you see right there? So I have x times y, and I'm going to put it like this. X times y is equal to a to the n. Okay, so now I'm going to go ahead and turn this into its logarithm format. So log of a of x is equal to m. Let's see if that's true. A to the m is equal to x. I hope you can see that, yes? And I'm going to do the same thing with this guy. I'm going to turn it into its logarithm. I know that log of a of y is equal to n. A to the n is equal to y. So far, so good? I hope so. Okay, so now I'm going to go ahead and showcase what we have. We have m is equal to log a of x, and n is equal to log a of y. Okay, So now I'm going to do the same thing to this guy. This guy right here, I'm going to say log of a of xy is equal to m plus n. Again, look at this. I'm going to use my counterclockwise rule. A to the m plus n equals xy. And then, finally, all I'm going to do is I'm going to, instead of writing x and y, I'm going to simplify it some more. So remember that m is equal to log of ax and n is equal to log of ay. So now the final rule says the following. Log of a of this product is simply log a of x plus log a of y. So if you notice, in order to expand this product of logs, it expands through addition. Log a of xy expands to log a of x plus log a of y. Good thing about these videos is that you can pause, rewind, go back, rewind, ask me questions, go back, rewind, watch it again. So this is taking the multiplied rule in exponential analysis, converting it into logarithms and deriving the logarithm rule that says the product of logs expands through addition. Log of xy expands to log a of x plus log a of y. Okay, I'm going to move on now to, that was Parens Apply. Now I'm going to do the same thing now with difftract. So we need to know this. This is pretty big information in order for us to understand the logarithm rule. So remember, difftract said, if I have an exponent and I'm dividing by another exponent of the same base, really all I have to do is subtract the powers. Okay, same thing I did before. I'm going to go ahead and let x equal a to the m, and I'm going to let y equal a to the n. Okay, so what does this mean? That means I have x over y is equal to a to the m minus n. All I did is, that was my x, that's my y, so all I did is use substitution right there. Okay, so I'm going to go ahead and now again convert this to its logarithm formula. So I know that log a of x is equal to m. Again, a to the m is equal to x. And same here, over here, I'm going to say log a of y is equal to n. I'll put parentheses. A to the n power is equal to y. So I hope you can see that. Okay, so now I'm going to do the same thing with this guy. So I'm going to say log a of x over y is equal to m minus n. Again, a to the m minus n power is equal to x over y. Okay, so now all I'm going to do is m and n. M is that, n is that. I'm going to simplify, so I now know that log a of x over y is equal to log a of x minus log a of y. So what does the rule say? When I'm dividing logs, this expands into subtraction. So that diff-tract relationship is still there, okay? So moving on, hope you can see that. Remember, all these rules are very important. I'm going to showcase a couple of examples because you have lots of practice coming your way. So I'm going to go ahead and do my next one. So this is now Parens Apply. This is the rule for Parens Apply. If I have an exponent and I decide to raise it to another power, all I really have to do is multiply the powers, right? So that's Parens Apply. Okay, so I'm going to go ahead and say, let x be a to the m. Okay? So if x is a to the m, then that means x to the n is really a to the mn, because if x is that guy and I raise it to the same power, to another power, then I have this here like that. Okay. So now the first thing I'm going to do is I'm going to convert this into its logarithmic form. So again, log a of x is equal to m, because a to the m power is equal to x. Same thing over here. Now here I have log a of x to the n is equal to mn. Again, a to the mn power equals x to the n. Okay, so now I'm going to go ahead and convert this guy, just the m right there, and back into terms of x. So I recognize that I now have log a of x to the n is equal to the m, which is that guy, and the n. So I'm going to put the n here, right? And then I have log a of x. So this is the formula right here. So if I have an exponential function, right, and I raise it to an additional, it becomes a product. So now if I have a logarithm with higher order power, that higher order power becomes a coefficient. It becomes a multiplying factor to the log. So it becomes a coefficient in front. And this is going to tie back into calculus. You'll see this, how this happens. Okay, moving on. So now you have some tools, okay? Let's talk about those tools. So I'm going to go ahead and give you a little overview of the important log rules you should know. These are log rules, okay? The very first log rule we should know is that log of 1 will always be 0. Log a of 1 will always be 0. Why? Because any exponent to the 0 power will always equal 1. Okay? Okay, next rule. Log a, I'll put parentheses, of a is always going to equal to 1. Why? Because any base to the first power will be that base itself. Okay? All right. Now, do the next one. Log a of xy is going to give me log a of x plus log a of y. Log a of x minus over y is going to give me log a of x minus log a of y. And then log a of x to the n is going to give me n log a of x. So these are the rules in essence. Let's talk about them real quick. Notice that these over here on the left side are compressed rules, and these over here on the right side are expanded rules. So we're going to need to know how to expand. So if I give you something in this format, you have to expand it to this format, and vice versa. If I give you something in this format, you must know how to compress it into this format here. So we're going to go ahead and do a couple of examples using these rules. First, we're going to do expansion. So I'm going to say rewrite the logs in expanded form. In expanded form. So I'm going to start with log 4 6x to the 5th power. So I have a couple things going on here. I recognize that I do have some type of product and I do have a higher power. So I recognize that I'm going to expand this by, this becomes log 4 of 6 plus log 4 of x to the 5th. So notice, this is like, there's a product, so that's why it expanded through addition. But I still have a power here, so I must finalize that one. So that's going to be log 4 of 6 plus, remember that higher power becomes a coefficient in front of it. So 5 log 4 of x. And this right here is my expanded log. Okay, one more. Let's do another one. Let's do some diff track. Let's do log 7 of 3y to the 4th over x cubed. Okay, so I noticed that there's higher power on both of them, but there's a product here, okay? So I recognize that that product is going to be plus, but there's also division, so there's going to be a minus. So this is going to be log 7 of 3 plus log 7 of y to the 4th minus log 7 of x cubed. Because, again, the products become sums, and the dividers or the divisions become a difference. So now I still need to do my the higher power into coefficient. So this will still need further simplification. Log 7 of 3 plus 4 log 7 of y minus 3 log 7 of x. Okay, and so this right here is my expanded version of that. So I haven't thrown in any natural logs. Let me go ahead and throw in natural logs, because natural logs follow the same thing of logarithms. A natural log is just the exponential function to the natural exponent. So it's just ln and e are the inverse relationship. So let's go ahead and do one more. Let's expand ln of 3xy to the 3rd. So remember, I got 3 times x times y, so there's going to be a sum there, and then I have a higher order power. So that's going to give me ln of 3 plus ln of x plus ln of y to the 3rd. And I need to go ahead and further simplify that one. So my answer is going to be ln of 3 plus ln of x plus 3 ln of y. Bum, bum, bum. That's my expanding examples. Let's go ahead and see now if I compress. So I'm going to compress, right? So I'm going to now condense it. So in condensed form. Okay, so let's do an example. I have a log 2 of 10 plus 3 log 2 of x. So now I'm going to work backwards. I'm actually going to go ahead and understand that the sum really means a product, and that coefficient really becomes a power. So I'm working backwards. So this becomes log 2 of 10, and then the x, but with a power. And that's my answer. Right there. So I can show you I'll do this one over so you can see. So I have log 2 of 10 plus log 2 of x cubed. So I took that 3 and I put it up in the front. So I'm working backwards, right? So now I recognize that they both have log 2, so I can go 10 plus x cubed, right? And I recognize that x plus y is the same thing as, right? I can expand this now. I mean, actually condense it, sorry. Log 2 of 10 times x cubed, like that. And so this simplifies to log 2 of 10x cubed. I just wanted to showcase that extra step just because I know this is new for all of us. Okay. Let's do one that has some subtraction in it. So we want to compress this one. 4 log 12 minus 4 log 2. Now notice that whenever there's no value here, it is base 10. So whenever you just see log, it's assuming base 10, okay? And this is the only value that your calculator can actually use because your calculator is a base 10 analysis. Okay, so I do recognize that I have coefficients on both. So that's the first thing I'm going to do is I know that I have log 12 to the 4th minus log 2 to the 4th. Okay. So I now recognize that I do have a subtraction. So this is going to give me log 12 to the 4th over 2 to the 4th. Okay. And I do recognize that this is going to simplify because there's no variables here. So I am able to simplify this. So I believe that's going to give me 1296. Since they both have to the 4th power, I'm able to then analyze it. Or you can even go 12 to the 4th. That's that divided by 2 to the 4th. And it'll still give me 1296. So this is going to give me log of 1296. Okay. And we can't forget our natural logs. So I'm going to go ahead and do one more example. And I have 3 ln 3 minus ln x plus ln x minus ln 9. Okay. So the very first thing I'm going to see is notice this entire expression has that 3 here. So I recognize that I'm going to first do this before I plug that power in. So I recognize that I have a 3 with ln 3 over ln x there. So that subtraction becomes division. So it's the subtract analysis, right? And then I recognize that I have plus, which becomes a product. And then this also has to become something. So this becomes, the plus is the product, right? And then I have ln x over ln 9. So this 3 now has to come up here, yeah? So I have ln 3 cubed over ln x cubed. So I took that 3 and put it to here. Because it's a ratio, this 3 applies to both. Okay? And then I have ln x over ln 9. Okay. So I'm able to simplify a couple of things here, right? I now have that 327, ln 27 and ln 9 can simplify, and that ln x and ln x cubed can simplify. So I'm going to go ahead and just, it's multiplication, so I'm able to work with that. So I have ln 3 cubed over ln 3 squared, ln 9 is 3 squared, and ln x over ln x cubed. So my final answer, 3 and 2. So 2 of these are going to cut out 2 of those. So this is going to turn into a 1. So 3, that's going to give me ln 3. And then this guy's going to kill one of those. So I have ln over x squared like that. So ln 3 of x squared, 3 over x squared is my final answer right there. Okay. I hope you enjoyed this video. You're going to see your homework soon. Have a good day, guys. Stay safe.